Alright, welcome to party trick number something. I'm going to pour some water in an empty Coke can, add a little ice to a bowl of water up here, and grab some tongs. I'm going to heat up the bottom of the can here. So you're going to want to take some observations about this. You can either use a scratch piece of paper, you can write your observations down there, or you can use the back of the cut and paste maybe that we did and make a column for observations, a column for inferences or why you think it happened, and then I'll offer an actual explanation. Alright, here we go. Just call me the can crusher. Alright, so pause the video, write down why you think that happened, either on a piece of paper or on the back of your cut and paste. Welcome back. See how your inferences compare to the actual explanation. So on the back of the board here, what I do is I have a heat or a burner here like I had in there, a Coke can. And let's talk about the Coke can before we ever start doing anything to it. There's air in here from the atmosphere. And there's air out here from the atmosphere, and that air is in the form of a gas. And that air is moving around, pushing on the outside of the can. It's also inside the can, so it's pushing out. And since there's an opening here for air to go in and out, you're going to end up having the same amount of pressure pushing out as you have pushing in. So pressure outside and pressure inside is going to be the same. That's why the can initially doesn't implode or explode, because the pressure is the same on both sides of the can. And so what we do is we put in some water here, liquid water, and when we start heating it, this liquid water starts turning into a gas. And pretty soon, this liquid water is gone. And by the way, when it's turning into the liquid water or water vapor, I'll just put a V here for water vapor, it's probably pushing most of these other gases out. So I end up with a can mostly full of water vapor. And because it can't escape, a lot of this water vapor is probably even leaving the can. But in the end, the pressure inside the can and outside the can are probably still pretty even, just because it can freely escape. So I have water vapor now in here instead of oxygen, and probably still a little water left at the bottom. We'll just get rid of it. Okay, so all the water is water vapor now. It's still equal pressure, both sides. Then we take the can and we turn it upside down. And let me draw the water vapor that was initially in here. And of course you have air outside. And before the can hits the cold, again, the water vapor hitting this side and the air hitting this side is probably the same. But as soon as the can hits the cold water, this water vapor does what? It condenses, turns back into a liquid. And so this water vapor, I'm going to start erasing them. Okay? This water vapor now turns back into a liquid. I'll just represent it condensing around the edges of the can, or it could probably even condense back into the actual water down here. It's condensing, so there's not much gas. There's probably still some, so I'll draw one water vapor molecule left. There's not much gas inside the can. And the gas is what creates the pressure in the can. But now there's not many gas particles pushing. And so what happens is this pressure inside the can goes way down. So there's hardly any pressure. So I'm just trying to draw a little tiny arrow here compared to the amount of air pressure outside the can. So what happens is, because there's very little pressure inside and a lot outside, that can gets crushed. And it gets crushed by our own atmosphere, okay, because there's a difference in pressure. So basically, through the water vapor condensing back into a liquid, it gets rid of the pressure in the can, and the can implodes. And I become a can crusher.